Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
We are beginning with a very interesting topic, triangles. In triangles, we are going to talk about congruency. If this is the stepping stone for many of the other topics. For example, if you know triangles, you can then easily tap onto your next chapter, isosceles, midpoint, rectilinear. Many more chapters are dependent on this topic itself. So this is the base. If this base is not clearly understood, it's going to be tough later on. So I want everyone to focus with the first exercise. If your first exercise becomes your base, which becomes very strong, then you will be able to tackle all the other topics for sure. So we're talking about congruency. Basically, we are trying to prove two triangles congruent. Why do you want to prove two triangles congruent? So if you can prove two triangles congruent, then all the other parts of that triangle also automatically become congruent. That other parts, we are going to talk about that in the second exercise. I just gave you the base that why are we proving the triangles congruent. Now to prove two triangles congruent, there are 5 techniques. Okay, so technique number 1, it is called Sss test. Sss test means all the 3 sides are equal, not of one triangle. Let's say triangle ABC and another triangle PQR. So you'll have AB equals PQ, BC equals QR and AC equals PR. Then in this case we will call the two triangles congruent. That means triangle ABC congruent. Congruent means equal to with a horizontal S above it. That is the sign of congruency. Congruent to triangle PQR by SSS test of congruency. So there are 5 different tests as I told you. The first and the basic test is SSS. SSS meaning all the 3 sides, side test. So this is an abbreviation allowed by the boards. So you can say SSS test when 3 sides are equal. The second test that we are going to talk about is Sas test. So side, angle, side. A is angle and S is side. Before we move further, in one triangle how many parts do you have? Any idea? Alright, in one triangle if you're telling me 3 parts, that's wrong. It has 6 parts, 3 sides and 3 angles. So if I take this triangle, let's consider this another triangle ABC. AB, BC and AC are 3 sides and angle A, angle B and angle C are 3 angles. The rule is if you want to prove any two triangles congruent, you need to prove any 3 parts equal. If 3 parts are equal, then the triangle is automatically congruent. But in these 3 parts, there has to be compulsorily minimum one side, at least one side. More than one side is fine, but minimum one side. It can't be 3 angles. Okay. So what are the possibilities? SSS, SAS. Let's introduce one more angle. So it becomes AAS test. Angles can be in different places also. So ASA test. One more test which is special test called as RHS test. What is that? I will talk about that later. And sixth one is ASS, 2S and 1A. The name itself looks a little bit weird, right? As. So this test is not applicable. Why? I will tell you that later, but this is not applicable. So at any point of time if you are using ASS test, you know what does it mean. So please don't use it ASS. You can use any of these 5. So we finished the first one SSS. Second one SAS. That means 2 sides and the angle has to be in between those 2 sides. So if I say AB is equal to PQ and BC is equal to QR, then angle B will be equal to Q, not A or C. Okay, has to be B. So SAS test, A has to be between these 2 sides. So then I can say that triangle ABC is congruent to triangle PQR by SAS test, because now the angle is placed right between the 2 sides. The third one, AAS. So let's again consider the 2 triangles ABC PQR, AA and then S. So angle A P, angle B Q and BC equals to QR. So AAS. I could have taken this angle, then I would have taken this side. So AAS, but I can't say A and then S in the middle. If S is in the middle, then it will become ASA test. Are you getting the difference? So I will say again triangle ABC congruent to PQR by AAS test. The next one, ASA. Now S is in between the two angles. So if I take ABC and PQR, if I take A and P, B and Q, then AB will be equal to PQ, the side in the middle. If I take B and Q, C and R, then BC will be equal to QR, the one in the middle. Are you getting it? So I will say triangle ABC congruent to triangle PQR by what test? ASA test. ASA test. Are you getting this now? ASA. S is in between the two angles. See, the placement is very, very important. And last one, RHS. What is RHS? Right angle, hypotenuse, and any one side. So ABC, PQR. So one is a right angle, second is the hypotenuse has to be equal, and third is any one side, whether AB, PQ or BC, QR, anything will do. So let's take these two. Alright. So now I will say triangle ABC congruent to triangle PQR by RHS test. Now the most important thing you need to remember for this RHS test, what happens with people is the moment they say 90 degree, the moment they see 90 degree, they immediately write RHS test. No. R means right, then hypotenuse has to be equal, and then one more side, because at times they confuse you by giving 90 degree, they give you hypotenuse and they give you the third angle. Then it doesn't become RHS, it becomes AAS. This test it is. So you have to see whether it is RHS, right angle, hypotenuse and side, or right angle, hypotenuse and A. If it is A, then there is no such test, it becomes AAS test. So basically in this topic, you are going to prove two triangles congruent using these 5 tests. If you know these 5 tests, you are sorted. Now the only thing you need to understand is how to present these sums. So we will do the first sum and you will get an idea. So I call this as 5 golden steps. When you say 5 golden steps, what does it mean? First step is the name of the triangle. Then the next 3 steps, that is second, third and fourth, are basically the parts that you are trying to prove congruent, or that they are already equal. So 3 parts. And the 5th one is the names of the triangle with congruent side by the name of the test also. So 5 golden steps. How are you going to write it? First sum, I want everyone to pay attention and then you can move ahead. So 2 triangles ABC and DEF given. 1A. They say AB equals DE, BC equals EF, and angle B equals angle E. How will you prove these 2 triangles congruent? So 5 golden steps. Listen, see, don't start. Next sum onwards, then you can begin on your own. Always have the habit of writing statement number. So let's say if this is your question number and this is your margin, statement number has to be on this side of the margin. So for example, like this. So that's your margin. I have made it like this, but obviously it's going to be straight. So question number on this side of the margin, and statement number on right hand side of the margin. Left hand side question number, right hand side statement number. So number 1, in triangle ABC and triangle DEF, that's your first step. That is the name of the triangles. Number 2, what is given? So AB is equal to DE. You always have to mention the reason. So in this case it is given. Given is a reason, that means it has been already given to you. Next is the angle. Go as per the sequence, don't go as per this. See, you know what test it is, right? What test is it already? Looking at the signs only you can identify. Superb. Sas test. Since it is Sas test, what are you going to do now? So first S, next angle. So say angle B equals angle E. Again the reason is given. And fourth one, BC equals EF. Reason again is given. So you got 3 parts, and finally the 5th step. Therefore triangle ABC is congruent to triangle DEF by SAS test. So only 5 steps and your 2 triangles are congruent. These same 5 test steps we are going to use throughout the chapter. So I want you to get this very clear in your head. First is the name of the triangle, then the 3 parts, and finally the triangles with congruent sign and the name of the test. See, the difference between the first and the 5th step is here there is and here there is the congruent sign. Will you remember this? If you get this correctly, The entire topic is going to be very simple for you. Let's pick up one more, 1C. Come on, put the congruent marks on your own this time. Write the 5 steps and then come back. Let's see how many of you all are able to manage. So AB equals to QR, B is equal to R, and C is equal to P. You can use dots, tick, cross, hollow, circle, anything to prove or to mark the two angles equal. So don't bother about it. What test is this? AAS test. SAA also you can say, whatever you want, but better it is AAS test. So steps. I hope you have finished and you've come back and you are not copying. So in triangle ABC and triangle QRP, see the names are different, it's not PQR, so go as per QRP. First one AB. Now if you say AB, you shouldn't say QRQ, you should say QR. Why? Because that is called one-to-one correspondence. Let me finish this, then I'll tell you what is one-to-one correspondence. Angle B equals to R and C equals to P. All three reasons are given. You can always write all the reasons together, and therefore triangle ABC congruent to triangle QRP by AAS test. What is one-to-one correspondence? Means A is corresponding to Q, B is corresponding to R, and C is corresponding to P. Why? Because B is equal to R and C is equal to P. Obviously A is equal to Q. That means if I write A first, then for this triangle I'll write Q first. If I write B next, then for this triangle I will write R next. If I write C over here, then I will say P. This is called one-to-one correspondence. So whatever comes first, second, and third. So see to it, throughout the chapter we stick to one-to-one correspondence. Come on everyone, 1E. This is slightly different. Use your brains. Let's see who gets it. These are the two triangles BAC QPR. This is 90 given, this is 40 given, this is 50 given, and you've been given BC is equal to QR. So I got one side equal, I got one angle equal, but I don't have the other angle. But what can you use and get the other angle? Absolutely, I can use in this triangle angle sum property and get this 50. So then this will be equal. So one angle, side, another angle. What test? ASA test. Sorry, ASA test. If I use angle sum property here and I get this 90, then this is equal, and this is equal. So it will be AAS test, not RHS, because only right angle hypotenuse, there is no side. So this particular sum you can prove by two methods. One ASA, second AAS. Whichever method you want, you try it. Okay. So come on, let's first get the third angle. So in triangle, always name the triangle that you are working at. So in triangle BAC, I will say angle B equals to 180 minus 90 minus 40. Reason will be angle sum property. And therefore I can say angle B equals to 50. So I managed to get this one 50. Now I got 1, 2 and 3. So come on, let's hit with the 5 golden steps now. Come on, pause, start on your own, come back once you are done. So in triangle BAC and triangle QPR, one-to-one correspondence maintain please. Fifth, angle B equals to Q equals to 50. This becomes your reason, so nothing else you need to mention. Then BC equals QR, reason given. And finally angle C equals to R equals to 40. Here you can say again given. And therefore we can say triangle BAC is congruent to triangle QPR by what test? ASA test. Amni managed to get this now? Great job. Was it simple? Yeah, little bit of application, that's it. Nothing great in these sums. Let's go to the next one, sum number 3. I want you to really think there is a small hidden clue in this. You have to prove that AP equals to BP. So what you must do is use some colors in order to mark what you want to prove. So I am saying AP is equal to BP is what I need to prove. If I want to prove AP BP, you have to pick up two triangles. Okay, how will you pick up two triangles? So let's say the first triangle and the second triangle. So you will first say join OA and OB. You can give your own name, whatever you want. Now if you look at these two triangles, if I prove the two triangles congruent by my 5 golden steps, then I can say AP is equal to BP, other congruent parts of the triangle. If the triangles are congruent, all the remaining parts become congruent. How many parts? 6 parts in a triangle, correct? Out of 6, if you prove 3 equal, the remaining 3 automatically become equal. You don't have to mention then anything. I'll explain that once we reach at the end of the sum. So first thing, prove the two triangles congruent by the test, whatever test you think about it, and then I'll come back. So two triangles, I can see 90. I can see OP equals to OP, that is one hidden thing, that is common side. Can you see? See, if I pull the two triangles out, this OP is the common side to both. That means OP is equal, correct? Then this 90 degrees. What else is equal? Is this equal? That is OA equal to OB. Can you tell me why are they equal? Radius of the same circle. So if they are both radii, obviously the length of both of them is going to be same. So let's write 5 golden steps. So first, name of the triangle. In triangle OPA and triangle OPB, you got the two triangles, the names of the two triangles. Now first part, I am saying OP equals OP, reason common side. Next, angle. So I will say angle OPA equals OPB. Why are the two angles equal? Because each 90 degree. That should be a reason. Each 90. Fourth, OA equals OB. Why is OA equal to OB? Common radii of same circle. Radii of same circle. Now that you have got 3 parts, I can say triangle OPA congruent to OPB by what? By RHS. See, right angle, hypotenuse and side. So RHS test. Since I got the two triangles congruent, now I can say the green part AP equals BP. Reason will be CSST. What is the CSST? Now you need to understand this well. Corresponding sides of, CSCT. Corresponding sides of congruent triangles. That means if two triangles are congruent, then their corresponding sides also are equal. If this was angle, let's say if I wanted to say this angle equal to this angle, then my reason would be CACT. Corresponding angles of congruent triangles. That means if you prove two triangles congruent, then you can say all the other 3 parts which you have not used are also congruent either by CSCT or CACT, or you can also say CPCTC. Let's use CPCTC, that is a better one. So you just have to say CPCTC for both. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. So you don't have to get into this SNC, SNA ka confusion. CPCTC. Whenever you're using an extra part. Once you reach to the final part, put a box so everyone knows what your final answer is. Let's go with the next one. Sum number 5. Prove that first they have given you B is equal to C. Prove that TPT matlab to prove that perpendicular from the midpoint of BC. So midpoint of BC, let's consider M the midpoint. So immediately put marks. Perpendicular from midpoint of BC to AB and AC. So perpendicular to AB, perpendicular to AC. So these two are perpendiculars. Let's name them as D and E are equal. Means your target is to prove that DM is equal to EM. That's what your target is. So basically to prove that DM is equal to DM EM. So how will I prove these two? So first pick up the two correct triangles. So obviously these two base triangles DMB and ECM, what all are equal? One is each 90. Do you have 3 parts? Find out. So first is 90. Second is this equal to this because they said that the base angles are equal. Third is midpoint, so these two parts equal. So RHSS nahi hai. So no RHS test. AAS test. What is it going to be? AAS test. And then you can say this is equal to this. How? CPCTC. Super. Come on, hit it. So first 5 steps. in triangle DMB and triangle, see DMB, it has to be EMC because this is equal to this and B is equal to C, 1-to-1 correspondence, EMC. First part, angle D, so name it properly, MDB. MDB, so MEC, see M first, then the congruent angle and then B equals to C, so B ke jagah pe you will get C, that is MEC, each 90. Next one, first angle we said, that is this. Now get to this angle, DBM equals to ECM, base angles, or you can say B is equal to C, the same thing. And fourth, BM, so don't say MC, it will come CM, okay, because B ke jagah pe C has to be there. 1-to-1 correspondence, reason would be M is the midpoint. Once we got the three parts, I can say triangle DMB congruent to triangle EMC by what test? Sss test. Once the two triangles are congruent, what can I say now? Therefore DM is equal to EM by what test? By CP/CTC. What is CP/CTC? Corresponding parts of congruent triangles are congruent, so DM becomes equal to EM. Did you get it? Is it interesting? You will enjoy. The more you get used to this chapter, this is going to be fun now, okay, so don't bother. Sum number 8, again a simple sum. Just read the question carefully and see what has to be done. They say perpendicular from M to AB and AC. So perpendicular from M to AB, perpendicular from M to AC, let's call them as D and E, are equal. So these perpendiculars are equal, that means DM is equal to EM is what you got to prove. How will you prove these two equal now? Think. So first two triangles. Before we get into it, how the diagram was generated. They said AP bisects angle this one. So bisector is already given. And then the perpendiculars we drew it. So if I take these two triangles, one is each 90. Second is this angle which is bisecting. What is the third part? Common side. Very good, you'll have become intelligent. Common side. Therefore triangles are congruent by what test? R trap. RHS nahi hai. RH, where is S? S is not there, you have to prove S. A is there, so it is going to be AAS test. Angle, angle and side test. Once the triangle is congruent, then say this is equal to this by CP/CTC. Come on, hit it. So first one, 5 golden steps and then CP/CTC straight away. I am sure everyone can get it. You want me to tell you the steps? In triangle this and this is equal to this is equal to this, common side, triangle is congruent, therefore CP/CTC. Come on, hit it. So in triangle DAM and triangle DAM, so EAM, 1-to-1 correspondence, don't forget. Angle MDA is equal to MEA, each 90. Third one, angle DAM equals to EAM, given. And finally AM is equal to AM, common side, and therefore I can say that triangle DAM is congruent to triangle EAM by what test? AAS test. Once they are congruent, therefore DM is equal to EM. How? By CP/CTC. This is very important. CP/CTC, very important part. If you prove the two triangles congruent, all the other parts are equal by CP/CTC. Did you manage to get this? Super. Let's go to the next one, sum number 9. The ninth one, the diagram, they say ABCD is a parallelogram. Parallelogram means opposite sides equal and opposite sides parallel. Both things you can use. First one, they want you to prove triangle DCE. So I am marking it in black so that it is easily identifiable. And triangle EBL. So can you see the two black triangles? How will you prove them congruent? You need three parts. So first one, they said E is the midpoint. So this is equal to this. Second, Superb. Who got this? Very good. Vertically opposite angles. And the third one, I'm giving you the clue. Parallel. Yes. This is equal to this. Can you see the Z formation? Yes. That is alternate angles. Therefore, the two triangles are congruent by what test? So look at one triangle and look at the marks. A test. So therefore your triangles become congruent. How to go to second and third, that we'll talk later. First let's prove the two triangles congruent. Come on everyone, 5 golden steps. So step 1, name the triangle. In triangle DCE and triangle LBE, 1-to-1 correspondence please maintain. Okay, first one angle DCE, yeah, equals to angle LBE, alternate angles. Next one, EC equals to EB, you can say E is the midpoint. Next one, angle CED, this one equals to BEL, vertically opposite angles, and therefore the two triangles DCE is congruent to triangle LBE by what test we said? ASA test. Now that your two triangles are congruent, so put a box to it. That's the first part. Now how will you go to the second part? Use some logic and tell me how will you achieve your second part. So second part is AB equals to BL. AB equals to BL. So see, you proved these two triangles congruent. Can you say DC equals to BL by CPCTC? I'm giving you the clue. And DC equals to AB, opposite sides of parallelogram. So this equals this equals this, therefore both of them are equal to each other. This is called property of association. You are associating these two, then you are associating these two, and therefore final association of these two. Are you getting it? So how I am going to write? If you still not got it, have patience, I'll get it for you. DC first and second, so BL first and second. How I am getting this? CP CTC. But DC is already equal to AB. Why? Opposite sides of parallelogram, and therefore DC cancel in your mind. What is left? Write it down. That is AB equals to BL. That's what is your second part. This is called association. 1 equals to 2, 1 equals to 3, therefore 2 equals to 3. Are you getting it? Perfect. Now the last part, AL double of DC. How will you get this? AL double of DC. So where should I write? I don't want to go on to the next page. Chalo, let's go to the next page so that it becomes more systematic. Now see carefully, okay, how are we going to get this last part? AL double of DC. We were on step 8. So continue the same steps. Step 9. I will say AL is equal to AB plus BL. AL is AB plus BL. AL AB. What is AB equal to? DC. So instead of AB, I will say DC. What is BL equal to? DC again. So here also I can write DC. Reason I will have to mention from. What steps were they? 6, 7 and 9. So from step number 6, 7 and 9. Finally, AL DC plus DC becomes double DC, and magic has happened. AL double of DC. So what did we do? We just using simple steps. AL, break it into two parts and give their correct names or different names what they are equal to. So automatically you get your final answer. We're just using simple basic steps, common sense, nothing great. This is no rocket science. So don't worry at all. I'm there with you. Come on, I want you to try the next one, sum number 11. 11 is also a beautiful sum. It's been given that BD is equal to EC. These two are parallel and these two are parallel. So the moment you see parallel, what should hit your mind? Alternate angles or corresponding angles. Okay. Now your target is to prove that BG equals to DF. To get BG and DF, I'll have to pick these two triangles. Correct. So I'm pulling them out. First triangle, second triangle. GBE and FDC. 1, I can say this is equal to this. Can you say why? I said B is equal to D from these two triangles. Can you tell me why? Alternate angles, correct? Sorry, corresponding angles. See, this is parallel to this. So one angle being generated here, second angle here. So both will be equal by corresponding angle. Second, I can say E equals to C. E equals to C. Why? Again, can you see these two sides this time and these two angles here? So again corresponding angles. So we got two angles for the two triangles. Now I need the third part. Third part, you got to be little smart. So pay attention how I am getting the third part for you. They have given you only BD. They have not given entire BE. Only BD, which is somewhere in the middle. Okay. So BD is equal to EC is given to us. What I now do is I take this middle part which is missing and I add that to both sides. This is a very important step, and reason will be adding DE on both sides. Okay, so what do I get now? Now be careful and tell me what you are going to get. BD plus DE will be what? BE. EC plus DE will be what? DC. Does that suffice your purpose? BE right over here and DC right over here. Now can we prove the triangles congruent? Yes. How? ASA test. So write your 5 golden steps. So that's how you generate this. So sometimes the third part is not given, we have to generate it. So first generate, then 5 golden steps. So first one, in triangle GBE and triangle FDC. First step, angle GBE is equal to angle FDC. Why? Corresponding angles. Second one, BE equals to DC. Why? From statement number 3. This is DC. Next one, angle, this one, GEB equals to FCD. Why? Again corresponding angles. And therefore I can say triangle GBE is congruent to triangle FDC. How? So by ASA test. Once I got the two triangles congruent, now I can say BG equals to DF. BG equals to DF. Why? CP CTC. So I got my first part. Further, the second part also direct. CF is equal to EG. So EG equals CF. Again why? So CP CTC. See, since the two triangles are congruent, automatically the other two parts of the triangle, that is GB equals to FD and CF is equal to EG. Both are equal by CP CTC. Did you manage to get it now? So once again, let's get the entire sum. They asked you to get BG DF. So that gave us the clue, the two triangles. We pulled the two triangles out. We took two corresponding angles because they were parallel. See, anything that is given in given is very crucial. That helps you to get something. So here they had given us two parts parallel. That helped us to get the two base angles. Then BD and DC, BE and DC I wanted. So I added this part DE in the middle to both the parts over here. And I got the third part. Once I got the third part, then 5 golden steps. Once the triangles were congruent, CP CTC. Easy. So now you understand one thing. The most difficult question in that, what can they give you? They can give you number 1. You have to prove the two triangles congruent. Number 2, CP CTC. And number 3, generate the third congruent part. Okay. So third congruent part, once you generate it, then the congruent triangles and CP CTC. Okay. Let's go to the next one. I want everyone to try sum number 13. 13 is not difficult either. It's a lovely question. You will enjoy it. BL is equal to CM is given. So BL is equal to CM. Your target is to prove that AD is the median of this triangle. That means, in short, you need to prove that median matlab bisecting the base. So your target is to prove that BD is equal to CD. So how will you prove BD is equal to CD? So pick up two triangles. So first clue obviously they gave. So this triangle and this triangle. One is each 90, second is this equal to this. What is the third part? Vertically opposite angles. Once the triangle is congruent, I can say BD equals to CD by CPCTC. How will you prove the two triangles congruent? By which test? AAS. Don't go for R. So once you get your 5 golden steps, let's hit it then. So step 1, in triangle BLD and triangle BLD, so CMD. Okay, first one, angle BLD equals to CMD. Okay, next, angle DLB DMC, both are given to us. No, my mistake. BLD, and this is each 90, and here it is vertically opposite angles. And finally I can say BL is equal to CM. This is given, and therefore triangle BLD is congruent to triangle CMD by AAS test. Once the triangles are congruent, then I can say BD is equal to CD CPCTC, and therefore AD becomes the median. AD is the median of triangle ABC. So that's your final step, what you wanted to prove. Did you get it? Yeah. Okay, let's go with the next one, sum number 14. 14 is also not that difficult, but still little lengthy. So first part, they say AB is equal to AC. Now if AB is equal to AC, then base angles also are equal if you need it. First part, BD is equal to CD, you have to prove. So if I want to prove that BD is equal to CD, what will I have to do? I'll have to take two triangles, ADB and ADC. I can say AB equals AC, given, AD common side and each 90. What test? Right angle, hypotenuse, side. Prove the two triangles congruent by 5 steps and CPCTC. Reach here, then we'll talk about the second part. So first one, in triangle ADB and triangle ADC. Yeah, these two triangles, I'll say AB equals AC, given. Then we will say AD equals AD, common side. And finally I will say angle ADB is equal to angle ADC, each 90. And therefore triangle ADB is congruent to triangle ADC by what test? RHS test. Once the two triangles are congruent, therefore I can say that BD is equal to CD. By what test? CPCTC. Not a test, but CPCTC. That's the reason. Now I want to prove that ED is equal to EF. So that's right over here. ED equals to EF. So which two triangles am I going to take? So one for ED, and EF is a part of this triangle. These two triangles, this is given bisector, each 90, common side. So what test is it? RHS? No. It's AAS test. So again 5 golden steps and then reach here. Come on, quick. So first one. How many getting these 5 golden steps by now? Brilliant. So first one, in triangle EFB and triangle EDB. EFB, EDB. I will say angle EFB equals EDB, each 90. Second part, FBE equals to FBE, so DBE, given. And how will I go ahead now? Step number 10. So 10 is going to be common side, EB equals to EB, common side, and therefore I can say triangle EFB is congruent to triangle EDB by what test? By AAS test. Once the triangles are congruent, I can say ED equals EF. How? So by ED equals to EF by CP CTC. So we got our final part. So two parts in the question. Basically they wanted you to prove the triangles congruent twice. Once here, second time here, and finally you reach here. Did you get this? Alright, great. Let's go with the next last sum. I want everyone to give your best with this one. Sum number 15. It's not difficult but slightly different. Let's see who picks it up well. First thing you got to prove is AB is equal to EF. These two sides. So take these two triangles. One is this equals to this. Second is this equals to this given. What will be the third part? Think. Parallel is given. Yes. Alternate angles. Oh, not this one. I can take these two. Correct? Z is forming here. Can you see the Z here? Yeah. So therefore the two triangles will be congruent by AAS test. Once the triangles are congruent, then I can say AB equals to FE. Second part we will think about it. Don't worry. So first get the first part for me. So number one, in triangle ABC and triangle ABC. So EFD. Second step, I will say angle ACB equals to EDF. Why? Because it is given. Second, angle ABC equals to EFD. Why? Alternate angles. And number 3, AC equals to ED. Given again. And therefore you can say that triangle ACB is congruent to EDF. By what test? AAS test. So once your triangles are congruent by whatever test you proved them, I can say AB is equal to EF. AB equals to EF by CP CTC. So we got the first part. Now for the second part, BD and CF. Now see, these are smaller parts of the entire side. So you're going to use reverse. One of the sums, if you remember, we added the common part. This time, see what we are doing. BC equals to FD. Again CP CTC. BC is the side of this triangle, FD side of the bottom triangle, so CP CTC. I say BC is equal to BD plus DC. Likewise, can you tell me what will happen to FD? CF plus DC. Can I cancel this? Yeah, because this comes on this side becomes negative, so I can cancel it. So what is left now? BD is equal to CF. Magic has happened. That's what you wanted to prove. So that step we added this step we removed the addition out. You're going exactly reverse. Nothing great. Guys, this topic is very interesting. If you pay attention, you will get it. If you not got any sum, please go rewind it. You will 100% get it. Alright. See to it you are very sure about this topic. Don't copy, don't cheat. Otherwise you're going to mess up all the following chapters. Alright. For homework, I want you to do 1B, 1D. Sum number 2, 4, 10 and 12. These sums I want you to do as your homework.
Hope you had a lovely mathematics experience with the Rough Book, our learning companion.